I was just about to move on to problem 1b, but then I realized I totally did this. Well, I did it right. I just had the wrong number. Alright, so what he wants for this problem is for us to use this information to find I of L just before the switch closes. So this is in a steady state, which is to say that you still have your source, Vs. You've got only one resistor because the other one is outside of the circuit. At this point, it's on an open circuit. Therefore, it basically doesn't count. This is R1. L, the inductor, because this is a steady state, the inductor basically in effect goes to be just a wire, a straight wire. Okay? And that has to do with, I'm sure, the function having to relate the voltage, the inductance, and the current. I'm not really up on it right at this moment. So here's our IL. Well, in this case, it's pretty clear that I is going to be the same everywhere. There's only one path I can follow. It can't divide up. So Kirchhoff's current law, everywhere you look, it's just going to have the same in, the same out, and it's all going to equal 0. So we know that this IL is constant. So we know that the I is constant. So IL is the same as IR, where IR equals Vs divided by R. R1 specifically. What I did wrong last time was basically I used R2, not R1. Whoops. Yeah, that'll give you the wrong number. Hope I don't do that on the quiz tomorrow. So IR equals IL at this particular point. This is not always true, it's just at the point we're looking at. Now we know that this is Vs because with Kirchhoff's voltage law, we have these two voltages, and if we do a loop, let's call this plus and minus. We do a loop, sum them all up. We've got a positive R1, and then this movement here is negative because you're going from the negative terminal to the positive terminal. So minus Vs equals 0. That should be V1. Sorry. So the voltage across the first resistor is equal to the voltage of the source. So we substitute that back in here. Pretty obvious, pretty simple. Alright, so IR equals IL. IL is equal to 12 volts, which is from right here, over R1, 4 ohms, which is right there. And this produces 3 amps. And that is your answer.